Hey guys, welcome to this week's Friday Focus. It is Miss Frizzle edition. I'm dressed up as Miss Frizzle for Halloween today. I want to do the question from your quiz. This question you guys struggled with, so I want to make sure that we understand how to do this in case we're asked to do it in the future. So the question is as follows. Write a balanced chemical equation for the acid-base reaction between phosphoric acid and the base calcium hydroxide. Use your balanced equation to determine the following. For each mole of calcium hydroxide consumed, how many moles of water are produced? So this is a challenging question, just that there's a lot going on before we can get to the answer. So the first thing we're going to do is write a balanced chemical equation for the acid-base reaction. I give you guys the names of the acid and the base. That's certainly not something you're responsible for. So I'm going to write down first phosphoric acid. And there we go. So we got phosphoric acid, which is H3PO4. And that's going to react with the base, calcium hydroxide. So the first step here is knowing how to write an acid-base reaction. What are the products? And then making sure we balance it. So for acid-base reactions, what we find is we've got this hydrogen often leading in our acids, and then we've got this hydroxide from our bases. This hydrogen will attach to that hydroxide, and one of the products will always be water. So water is always a product of these neutralization reactions. Okay. What is left from that interaction? So if these hydrogens form water, what is left from the acid is this phosphate. What is left from the base, if that hydroxide goes to water, what's left here is calcium. So the other product for acid-base reactions will always be some sort of salt. That's just a fancy term for ionic compound that dissolves in water. So that salt is going to be this ionic compound between calcium and phosphate. So that's the other product. So I just put an ionic compound on the paper. It is my job to make sure that ionic compound is electrically neutral. Make sure the charges are balanced. So calcium, if we look at the periodic table, it's in the second group, which means it's going to lose 2 electrons. So it's going to have a 2+ charge. Phosphate is one of our polyatomic ions, and we know that it has a 3- charge. So flippity floppity here, 2 is going to be the subscript on phosphate, 3 is going to be the subscript on calcium, so flipping those to make sure that it's electrically neutral. So this should be calcium with a subscript 3, I'm going to rewrite this. So it should be calcium with a subscript of 3, and then that phosphate with a subscript of 2. I need 2 of those packages. So anytime we put an ionic compound on the paper, we need to make sure it's electrically neutral. I'm just cleaning this up a little bit so we can start balancing. All right, now that we have our chemical equation on the paper, I'm going to take inventory of what I have. If you guys can recognize polyatomic, so phosphate is a polyatomic, and it stays together as a polyatomic on the other side, you can treat that as one of the things in the inventory. So I can keep that all together, and it's going to cut down on the number of atoms that you have to balance. Another pro tip here is I like to keep the atoms in the same order. So hydrogen, that way I can easily bounce back and forth. Oops. All right, so now we're just going to take inventory of what we have. So on the reactant side, I've got 3 hydrogens from my acid. And I also have hydrogen over here from the base. So distribute this 2 through. I've also got 2 hydrogens from the base. So 3 from the acid plus 2 from the base gives me a total of 5 hydrogens. I've got 1 of the phosphates, 1 of the calciums, and again, 2 oxygens. All right, do the same thing on the other side. So hydrogen, I've got 2 from the water. I've got 2 of these phosphate packages, 3 calciums, and 1 oxygen. So we've got a lot of balancing to do here. Nothing is balanced. There's probably a number of different ways that you could start to balance this equation. I'd probably stay away from the hydrogens. That's kind of a mess over here on the reactant side. So we could start with calcium or phosphate, either way. Let's go ahead and do these calciums. Just randomly thought that one. All right, so calcium, we've got 3 on the product side. That must mean we have to start with 3 on the reactant side. So I'm going to predict that it's not 1 molecule of calcium hydroxide that reacts. I'm going to predict that that's 3. Change my calcium to 3, but that is also going to affect the oxygen, and it's going to affect the hydrogen, so that 3 goes to all of these. So to get the number of oxygen, I take coefficient times subscript, so 3 times 2. So I'm going to have 6 oxygens. That also affects this second hydrogen here. So again, 3 times 2. Now we've got 6 hydrogens. So 3 plus 6, now we have a total of 9. Next thing I'm going to attack is the phosphate. So I've got 2 on the product side. I need to make sure I have 2 on the reactants. So I'm going to put a 2 in front of this. So 2 will affect the phosphate. So now I've got 2 phosphates. That also affects the hydrogen. So coefficient times subscript. So now I have 6 here. So that's going to change the total. 6 plus 6 gives me a total of 12. So the last thing that I need to balance are the hydrogens and the oxygens. So I've got 6 oxygens down here. I need to have 6 on the product side. So I'm going to put a 6 in front of the water. That's going to change the oxygen. It's also going to affect the hydrogen, but that's good because we kind of need it to. So we've got 12 hydrogen on this side, coefficient times subscript, 6 times 2, that's 12. Now we're balanced. 12, 12, 2, 2, 3, 3, 6, 6. So that's the balanced chemical equation. Now that our equation is balanced, now we need to answer this second question. For each mole of calcium hydroxide, how many moles of water are produced? So we're going to do a unit conversion. We're going to go from moles of one substance, change the unit to moles of another substance. So I'm going to write down 1 mole of calcium hydroxide. So that's going to start my train track. Let me do 1 mole here. All right, this is simply a unit conversion, so I'm going to set it up the same way that I always do. Mole of calcium hydroxide is going to come down here. And then my destination, whatever it is that I'm asking for, is going to go on top. So it's asking about water. So moles of water on the top. To change from 1 unit, calcium hydroxide, to another unit, water, we're going to use the coefficients from the balanced chemical equation. So here I see the number 6 is attached to water. So that number 6 is going to go on the top. Here I see the number 3 is attached to calcium hydroxide. So the 3 is going to go on the bottom. Multiply across the top, divide by the bottom. These units are going to cancel. So we've got 1 times 6 divided by 3 gives me 2 moles of water. So that was the answer. For every 1 mole of calcium hydroxide, 2 moles of water were produced. This was a challenging question. It's asking you to write a neutralization reaction. It's asking you to balance the neutralization reaction. Then it's asking you to do a stoichiometry problem with that information. So definitely a challenging problem, but each of those things are tasks that you are responsible for this upcoming exam. I hope you guys found this helpful. Have a great Halloween.